The Source Stepper is available on many platforms. It's available on all platforms that support the IDE, which is the Integrated Development Environment, and it's available as a TTY interface on all those platforms when you're not using the IDE, and on some additional platforms that don't support the IDE. It is, however, not available at this time on Solaris and or on AIX. In order to use the Source Stepper, the code you want to step through must be in a file. The file must be compiled and loaded into Lisp. The compilation must be done while the optimization switch, save source level debug info switch is returning true, which it does when the debug optimization quality is 3. And as I will say in the IDE, that could be done automatically, as I will show you, and also load source file info. The variable, the global variable, should be true. It's actually true initially, so unless you're turning it off for some reason, that's always going to be the case. Now, source stepping in the IDE, when the Source Stepper is, excuse me, when the Source Stepper, which I will show you in the next slide, is visible, compilation is done. Compilation using the IDE tools is done right, where right means for the purpose of having the stepper information stored in the FASL file. And you display the Source Stepper, you display the Stepper Dialog with the Stepper Dialog command on the Run menu. And we're going to see all of this in an example. It's just I put these things in the slides so that if people download them later, and they will be available, they'll see this information. So when you bring up the Source Stepper, this is what it looks like. It has a number of buttons, and it's got 3 panes where various different information is shown. When we actually start stepping something, you'll be able to see this. Now, once the Source Stepper is displayed, files that you compile and load using the IDE tools will be compiled with the source stepping information written to the file, and they will be loaded with this information being brought into Lisp. So we're going to see that happening at mains in the IDE. It's easier to get to use the stepper. You just have to bring up the Stepper Dialog, and then all the work you do from then on in normal development, stepping will be available. So we're just going to show an example of a simple function that we're going to step through. This function is defined in a file we call foo.cl, and in theory what the function is supposed to do, here's the source of it, is you give it a path name and an integer as arguments. It's supposed to open the file specified by the path name and then read the integer number of lines and print them out. And you must, in order to start stepping, you have to have at least one breakpoint. You set breakpoints with the :BR, which is short for breakpoint, top-level command, and you typically set breakpoints at function names. So you could do :br foo, and you set a breakpoint at foo. Then when a call is made to foo, the computation will stop and information will be displayed in the stepper dialog. If you don't want to be stepping, you just clear the breakpoints, and you do that with :br nil. So as I said, the function foo is supposed to read some lines and of a text file and print a number of them out as you specify. But there's actually an error in the function. It doesn't print the right thing. It simply prints the stream object rather than the lines that you've read. Actually, when I was coming up with this presentation, I wrote that function. It contains a couple of macros, and one of the things I'm going to show is that you get macro expansions as you step through. And I thought, well, I'm going to have to put an error somewhere, but the error I actually put in, I just, was an unintentional error, but it, I just typed the wrong thing, but it serves perfectly well for our purposes. So we compile and load the function and call foo with appropriate arguments. Actually, we're calling it on the source file itself, foo.cl, and we're saying print 10 lines. And we're expecting to see 10 lines from the file, but instead we just simply see a representation of the stream object, and that's obviously not what we wanted. So we're going to step through and see what's going on, and in order to do that, we have to display the stepper dialog. We must recompile it, because when we first compiled and loaded it in order to run our test, we didn't have the stepper dialog displayed, and so using the default settings, it didn't store step source information in the FASL file, so we have to recompile it. Now there's a little inconvenience, which is if you use the tool for compiling and loading, it will only recompile the file if the compiled FASL file is actually earlier, has a timestamp that's earlier than the source file. In that case, it will recompile the source file and load it. If the compiled source file has a timestamp later than the source file, it will simply reload it, and so we won't get the stepping information put into the FASL file. There's a little trick, which is if you've got the file open in a editor buffer, just add a character and take it out. Just make some trivial change that doesn't change the code and save it, and then you can do the compile and load again. Well, enough of the slides for a moment. Let's actually go and look at all of this in an example. And so I'm going to bring up Allegro Common Lisp, hopefully. Let's see, there we go. And as you can see, we have Allegro Common Lisp displayed here. We have a debug window, and we have a editor which is open to my file, foo.cl, and here's the definition of foo right here. Let me just, so let's start out. Here is how you compile and load a function. It's this little icon here that looks like a truck, and let me just make sure that everything's up to date. So we hit that, and it says, let's compile and load foo.cl, so we do that, and we get the loading message there. So now we're just going to try our function. So we're going to look at the file foo.cl, the actual source file we're looking at, and we're going to look at 10 lines of it. And there we go. Those are 10 lines, not from the file. They're just all representations of the stream object. So I'm not actually, it's not actually doing what I intended. So we can, go stare at the source code, but a little bit easier. Let's just try the stepper and go through it. So now we have to display the stepper dialog, run stepper dialog, and there it is. And then we have to recompile and reload the function. And we can't just click on compile and load right at this instant, as I said, because it will just reload the FASL file that's already there. So let's go back to the editor, just make a trivial change. We put in a space, we take it out, we save. Now the source file is later than the FASL file, so when we click compile and load, it will recompile as it has done. And now we can run this again. And as you can see, we didn't get the stepper, and the reason is we have to set a breakpoint. I keep making that mistake, so I thought I'd demonstrate it. You have to set a breakpoint in order to get the stepper to work. So we set a breakpoint at foo, and we call it again. And this time, it comes up. So here's the stepper dialog. In the top pane, it shows the form that we are stepping through, and this is the definition of foo. In the middle pane, it shows the form that we are currently at, and since we're just starting, those two are the same. And then in the lower of the three panes, there is some stack information having to do with well, the thing we can see here are the various arguments and the various local variables. Now, sometimes this information is useful and sometimes, or let me put it differently, some of this information is useful and some of it is probably less useful. Here are the two required arguments, path, which is foo.cl, and n, which is 10. It's usually useful to see those. And then there are a bunch of locals displayed, and sometimes those are useful to see and sometimes they aren't. But, excuse me, because you didn't, those are put in by the compiler, and some of them you might recognize and some of them you might not. Generally, you don't necessarily worry about this pane while you are sort of doing your initial stepping and studying. If the debugging is more complicated, you might pay more attention to this. Now, there's several buttons down here. Let's start with the next button. The next button just starts stepping through the form we are looking at. Excuse me. So you notice that the pane in the middle is changing. Let me just give a little bit more space to that because we're a little bit less interested in this example. Okay, my computer is a little bit oversensitive, and I don't want to quite, let's see if I can go, there we go. So every time we hit next, so when you call the function, the first thing it is this form, which is a block, and then the source code to the function. This is a block named foo. This is the standard way you enter a function. Then we get the with open file. Now, with open file, as I'm sure you all know, is a macro. So in the actual compiled code, you won't find any reference to with open file because it was macro expanded, and it's not a function, so there's no function call. This form was macro expanded and transformed, as we will about to see. But the information that was stored in the FASL file when the stepper information was collected and stored there has the macro form, and it's able to display it. So you are able to see that, okay, the next thing we're going to do is go into the code which results from the macro expansion of this macro, but you get to see the macro call. We click next again, and there's the macro expansion. When you have a with open file, you bind the stream variable s to the opening the file. You create a gensim, which you set to some value. Then you have an unwind protect, because with open file guarantees that if the file closes because of an error or something, it will protect the state. And then there are various other things, but the next thing you recognize is here is more or less the let form that we recognize. And we could scroll further down, but you can do macro expansions elsewhere. Let's keep going. So there's the call to open. And we're binding S to the result of the call to open. We're binding this gensim to T. Now we're in the unwind protect within the let statement that came out of the macro expansion, and so on and so on. And let's see, now we're down in the do times. Do times is another macro, so it doesn't exist in the FASL file, but it remembers what the macro form was, and it gets transformed into a call, into a do call, and you can see that this is a rewriting of the do times, where it's got a gensim which is set to the value n there, and then it's got a variable I which starts at 0 and is incremented by 1, and there's a test where, and so on and so forth, the usual macro expansion. And we keep stepping through, and so it does the read line, and the EQ line S, by the way, the read line says we should read from the stream S. We should nil. The second argument is, should we have an error on a, when it reaches an EOF and we're saying the end of file and we're saying no, and instead it should return some value specified here. Well, a good trick as the value to return is the stream itself, because you're guaranteed that it's not going to read the stream object from the stream, because it didn't even exist when the file was written. So that's a good test, but no, we've read a line, and then we get to the print statement, and we go back. Now, if we go back and look at our debug window, you notice that we have printed one line from the first line there, and that's the clue that there was a problem, and we look at this and say, oh, wait a minute, that's supposed to be print line rather than print S. S is the stream that we're reading from, and what was meant when one was writing this function was to say print line there, but, you know, brain wasn't working, and so I typed S instead, and that's why we were getting that behavior. Now let's go and look at this second button here, continue, and if you click on the continue button, it just typically goes through the form that you're stepping through, and that form has now completed, so we're not stepping through anything. And if we go back and look at the debug window, there are all the it printed out the stream 10 times. So that was an example of using the Stepper dialog, and I'm going to show you a little bit more, but let me go back to the slides just briefly. There we go. So here's some more information which is important. Stepping information makes the compiled file bigger. foo.fasl, as we originally compiled it, was about 3 kilobytes. foo.fasl with stepping information is 8 kilobytes, almost 3 times as big. You're going to end up with big FASL files, and if you have quite a large file and it has lots of things which the stepper has to annotate, you can end up with a very big file indeed. And so occasionally this can present a problem. The stepper dialog, I'm just repeating what we saw. You see the form you're stepping through. You see the form the stepper is at in the middle pane, and you see certain of the backtrace information, particular arguments and locals in the lower pane here. By the way, the area here, you get various information about that's considered useful, and in particular, it will, when it's displaying, you notice in this slide, it was less clear actually on this computer when I was doing it. There's sort of an orange color, and the orange color is telling you that you've got a macro form, and there are other colors, blue and green, which we're going to see in just a minute. You click on Next to step through, and we finally find the error. Print S should have been print line. Here are some more information. Macros are expanded. You see the macro and the individual forms. Relevant stack values are displayed. The form being executed is displayed, and colors indicate information about a form. The return button returns from the current from the current form being evaluated. The continue button usually jumps to the new breakpoint, and so often to the end of the form being evaluated, and so clears the dialog. Sometimes you have to press it more than once, but that's the way to get through. Closing the dialog does not stop stepping, but initiates the TTY stepper, and reopening the dialog usually reinitiates stepping in the dialog after a return is entered. But if you want to use the TTY stepper, just don't display the dialog. We don't recommend closing and reopening it. And if the dialog's available, there's probably no reason to use the TTY stepper. But I'm going to show you that in just a minute. And then there's the edit button, and I'm going to demonstrate all of that now. So there we go. So let's show a couple of those things. So let's just call foo again. And there we are. We're back to stepping. And so let me, suppose I just close the stepper there, and then we see that we're now in the TTY stepper. And when you're stepping using the terminal, it prints the information which is displayed in the various panes. And next is essentially, hitting enter is essentially equivalent to the next button. And you can see that a lot of the information which is displayed in the dialog is printed in the TTY stepper, but of course it's not, it's not, because it's not really possible for it to be displayed in as useful a fashion. So I can't imagine that there's any reason to use the TTY stepper if the dialog is available. I just wanted to briefly show it exists, and if you happen to be running a Lisp where the IDE is not available, so you don't have a stepper dialog, you can still use the source stepper, except on the couple of platforms where it's not supported, Solaris and AIX, and you get this information printed here. It's not as convenient, but it is there. So let's bring the stepper back, and This is a very small window on the computer, so I have to keep shifting between windows. So we hit return again, and Stepper Dialog wakes up again. So we're stepping through this. Now let me show you another couple of features. One is that if you click on a form, and the form print S is down here at the bottom, let's just click on it, and you notice that the parentheses turned red. And that means that we have established another breakpoint at print. Before, we only had the breakpoint at foo. So when you called foo, you would get a, it would break there and start stepping. Now we have another breakpoint at print, and if we hit continue, notice we jump down to that breakpoint. If we'd hit continue without having set that breakpoint, then we would have gone through the whole call to foo and they more or less cleared the stepper dialog. But we dynamically set a breakpoint, and now that's where we are. Now, secondly, let's look at the edit button. Now, the system has to know where the source file is and where the compiled file is. So when we hit edit, it opens the source file. It was already open. It knew that, so it simply displayed the editor. To the definition of the function, opens the source file that contains the definition of the function, and you notice that it has highlighted this statement that we are currently stepping through, that is currently the place we are at in our stepping, and has highlighted it. This makes it very easy once you have decided what form needs some work, because they, while you've stepped through, you've discovered there's a problem with the form. You highlight that form, you click the edit button, and the source comes up with that exact form highlighted in the editor. Not such a big deal with a 7-line program, but you have a 150-line program, much more useful. So we keep, we do a bunch of next, and we do continue, and we got through. So somehow I managed to unstep there. Let me go back to the debug window. And if we want to turn stepping off, we do break nil. That says remove all breakpoints. And now when we call our form again, well, I can't see it, so I'll just type it in. We don't get the stepper dialog because there's no longer a breakpoint. Now, we define two other functions in here. Here's the editor. We defined a factorial function, just the usual factorial function called fact, and we defined a variant of foo called bar, and it's identical to foo, takes the same arguments. We have corrected what we're printing down here. So let's set a breakpoint at fact and a breakpoint at bar, and just do a little bit more stepping here. There's fact, and here's, bar. And so now let's call bar, again with the same file, and this is a pretty weird function, by the way, which I was just showing. It takes the argument n, and then it's going to display factorial of n lines, if there are that many lines. That's a weird thing to do, but I'm just demonstrating how you're setting breakpoints. I'm not writing functions that necessarily make sense. So rather than doing 10, factorial of 10 is quite a large number, we're going to do 3. Factorial of 3 is 6, so we're, in theory, going to display 6 lines. So here's bar, and when we do, let's do a couple of nexts. But if we do continue, we end up in fact. We end up with the call to fact and another breakpoint, and it actually displays the definition of fact, and then we can, and it just, and let me just see, we got another one right there. You notice that it turned green, and that means that this is, well, it says right here, green highlighting indicates a source stepping form. Pressing step now will do source level stepping through fact. Actually, that should say pressing next or one of the buttons through here. But we're just going to continue, and we eventually make our way through. And I was just trying to get out, so we're now out of that, and let's go back and view the debug window. And there we go. It should be 6 lines. 1, 2, 3, 4, 5, 6. If we were looking at this, you notice that it's sort of annoyingly printing the quotation marks around each line. Read line reads a line as a string. Maybe that's not what we want, but we could go figure out why that's happening. We could use a different print function. And if we just do this quickly again, let me just show you the, let's do a continue, and that takes us to the fact, and there we go. That's just using the edit button again. All right, let me go back to the slides briefly. So breakpoints are indicated by red parentheses. You can add or remove breakpoints with the mouse. Continue jumps to the next breakpoint. And I demonstrated that by adding a breakpoint at print and, clicking again in the form will remove it. The TTY stepper, I showed that. There's no reason to use the TTY stepper unless if the dialog is available. There is, we're not going to go into this, but when you are going into a macro expansion, there are various ways. Let's just go back and look at the stepper dialog again. There are various macro expansion stepping actions. Into is the normal one, which just says display the macro expansion and then step through it. But you can have other options. We're not going to go into that here because there's sort of enough information already. In the TTY, this is done with what's called the slide option. Okay, just to remind you, that's really the end of the demonstration, but just to remind you, the compiled files can be very much larger when stepping information is stored. The actual code, the compiled code, is unchanged. That is, if you just compile a code with stepping information not stored, you compile a file, you end up with compiled versions of the various functions defined in the file. Those compiled versions, when you do save stepping information, are identical. It's just when you tell the system, please step through this function, it goes and looks at the FASL file, which has lots of information in it, like this call is a macro, and here's the macro form, and here's what the macro expansion looks like, et cetera, and therefore is able to display those things in the stepper dialog. But you haven't changed the compiled, the compiled function object is the same whether you've stored stepping information or not. However, if you have lots of macros and complicated things, the compiler can take quite a long time to generate all this information and write it to the file. And while these are somewhat pathological examples, we have seen examples where compiling without storing stepping information takes seconds or even microseconds, and compiling with stepping information takes a minute or two. So the compiler can be significantly slowed down if you are storing stepping information, although those cases are, well, they're perfectly reasonable Lisp code, but they're slightly pathological from the point of view of storing stepping information. The stepper is documented, and here is in the file debugger.htm. You know, I suspect that's actually debugging.htm, and I think that's a typo. There's a link, source step 1, that takes you to a section describing the source stepper. The stepper dialog is described on this page. And very important, if you want to use the stepper dialog, make sure that you have updated your Allegro CL 8.2 image, and because the stepper dialog is new, we are getting, we're using it ourselves and finding ways it can be improved. Customers are telling us, it didn't seem to work this way as I expected, or it would be improved if we did this. So we already have a number of updates available for the stepper dialog, and there will probably be more coming out, as we get more experience with it. So just be sure to do regular updates.